A lot of marketers have started talking about marginal CAC as opposed to average CAC. And this is a good thing. I absolutely love it. This is going in the right direction because marginal CAC answers the question that if I spend an additional $100 say in channel X, what is going to be the return from channel X? Return for specifically those $100. Average CAC does not tell you that. Average CAC tells you just the average. So the problem arises though when mathematical definition of it is arrived at. So the equation that a lot of these marketers that I see who are using it, again, their intentions are great, but just mathematically it's coming out to be wrong. This is the mathematical formulation that they're using, the additional cost divided by the additional number of customers acquired. So this is theoretically, it is fine, like only up to a point, but when you go into practice, when you try to apply this idea in the real world, this formula will not work because this is an analytic formula. This is just a regular algebraic formula, very static definition, and this is not going to work. This is going to fall flat. So what do we really need is going to be something that can be explained by this one chart only. So it speaks about 5 failure modes. Let us go through each of these one by one. The first one is that the static definition of marginal CAC completely invisibilizes the other forces that are working whenever we are talking about something like a market, right? Whenever there's spends and a product is getting sold, it's not getting sold in isolation. The paid marketing channels, the performance marketing channels, whether it's Google Meta ads or whatever, it's Amazon, these channels are not operating in isolation. Exogenous factors, the market conditions are there, competitive pressure is there, and also other things, other channels are also working, like organic and word of mouth. So these things are not considered whenever we are taking this sort of a definition. So those have to be taken into consideration as well. Otherwise, the concept of marginal CAC does not really arise, right? You have to probably qualify it in some way while you are defining it. So you are collapsing the effect of all different kinds of input variables or other external variables as well, anything that has gone on the input side of the thing, taking credit for the customers acquired for all those variables. But that's not the ideal way to define marginal customers. You have to have an element of causality in it, which if you look at this curve, which you look at this graph, the bold line, if you look at the legends that are given at the bottom. So by the way, the spends are plotted on the x-axis and the customers acquired are plotted on the y-axis, and the bold line, that response curve, is your true response curve. But the true observation, so there's going to be more spends, and more importantly, there's also going to be more customers. Those are given by the blue shaded region, and there are some true observed points there, and therefore there's going to be a gap, right? So if you take any 2 points A and B and you draw a line through those shaded regions, so any 2 given observed points, by the way, it's actually going to be a gap between these two, right? And that's the causal gap, or the gap that arises because there are other elements at play, other variables that are causing customer acquisition. When you're using that delta C by delta S definition, that's for those other elements or those other variables that have also caused or have contributed to customer acquisition. Those are also coming into the picture. So it's not really a true marginal cost or a true marginal CAC, because this is not telling you whether the cost was really incremental or causal. The second thing is also what we just walked through right now, is that it's not really the tangent. The marginal CAC definition is really the tangent at any given point, right? So you just need one point and you draw the tangent, and this will give you the marginal CAC. And then there is a corresponding observation point which lies in that shaded blue region, and the dotted lines that are going through it. So that point B and the point at which the tangent has been drawn, that actually gives you a gap, right? You can see that it's not the same, and that is called the secant, the one on the top, which is through that arc, any line that touches any 2 points of that arc. And if we now move to the fourth one, this is connected. I'll come back to the third reason that's given here, which is Ceteris Paribus. If we come to the fourth point, that there's no curve, no position, this means that you have only 2 points, right? And through 2 points you can only draw one line, which is why we have the secant, but you actually don't have the curve. So the curve is actually missing to us when we are using just the average, or when we are using this delta C by delta S formula for arriving at the marginal CAC definition. So the curve is not present to us. We don't really know the model. The model is unknown to us. But in this case, when we have the true response curve, it obviously means that this graph has been obtained after having the true response behavior, the true causal impact of the spends that has been generated. Again, some people might, of course, rightly point out that there are stronger causal methods, but yes, once you're doing something like, say, a marketing mix modeling or a more comprehensive statistical modeling or a machine learning modeling, then you're to a certain extent moving towards that causal impact isolation, where you're understanding that how much the spend really was responsible for customer acquisitions of, or how many of those customers. That's what is represented by this bolder, stronger line. No curve and no clear identification of the true effect. When you're talking about the marginal CAC, you want to also understand marginal CAC at any point, right? Why do you want the marginal CAC? You want to understand at any given point, if you spend, suppose, another additional X number of dollars, how much returns you can expect at any level of current spend, right? So that is what this chart will give you very nicely, this true response curve. But in the absence of the curve, what you're using are the observed points that you have. You're just using 2 points and drawing a line between those two and just taking the average value there by this formula. This is actually not giving you the marginal CAC, the true marginal CAC, because you don't have that curve, so you cannot go to any other point. Let's come to the third point, which is Ceteris Paribus. The meaning of this phrase Ceteris Paribus means that all things remaining equal. So obviously you don't have that possibility when you're using delta C by delta S, because you haven't really taken into account other factors that might have also played a role in the customer acquisition, right? So you have not really done the causal impact analysis. So it's in a way a corollary, an extension of the first point when we are talking about delta C not really having caused the acquisition of those customers. And finally, there's also direction asymmetry, and this is a very interesting point as well. So suppose you are on any given point on this curve, and then you're trying to decide whether or not to increase or decrease spend. Suppose you're considering that, right? That because either of these decisions could be correct with respect to your understanding of marginal CAC. Now, this is actually not going to be the same. The relationship will not remain the same once it's coming back, because this is what is basically called hysteresis. This is taken from physics, and the relationship might change when it's going in the reverse direction. So if we're in the upward direction and you have a marginal CAC there, and you have still not reached a saturation point, and it still makes sense to put in dollars there, it might not just mean that you're going to get the same pattern once you go the reverse way as well. So there is a directional asymmetry. When you have the true response curve, this does not matter, because you obviously have the entire formulation of the model, so the entire chart, the entire response curve is there with you. But when you are only talking about 2 points, when you are only using the delta C by delta S, this becomes a blocker. Let's actually think of it this way. If you have some difficulty understanding whatever we have discussed so far, that the ratio remains constant between marginal CAC and average CAC, and the ratio is marginal CAC is average CAC by beta. The spend levels keep increasing, and you'll see that the average CAC is also increasing, and so is the marginal CAC. But it's also important to see that the marginal CAC is higher. So this is the important point. When marginal CAC will always be higher when it's a diminishing returns curve, right? Because it might look like your CAC is low at a certain point, but it might be actually much higher when you're looking at the marginal CAC. That's precisely why you want to look at the marginal CAC, because your marginal returns will be much worse than what looks on an average basis. So despite the spend increasing and average CAC increasing, and of course marginal CAC being greater than average CAC at every point, you still see that the ratio is constant. So this is a very interesting property, but I must say that this specific property only holds true when we are talking about power law. The power law is where you are taking this sort of a formulation, and the beta is your spend elasticity. You start with the simple definitions of what is marginal CAC and what is spend elasticity. So your spend elasticity is given by this formula. So it's the change in the number of customers acquired over the change in the spend. So it's just the opposite concept of CAC really. And you can rearrange this in this form where it becomes dC by ds multiplied by S by C. And from there, through more algebraic manipulation, you can easily arrive at this thing where your beta is simply average CAC by marginal CAC. So you can see that the ratio of these two, like I was just saying, this was basically the constant, but this is only possible in the case power law is being used, right, to define the relationship between spend and customers. So let's also look at another case, like a general case, not just one. So we were talking about the power law. So these are the different kinds of response curves. So if the equation is a power law like we're just talking about, then of course it takes that particular form of average CAC and marginal CAC, and the ratio ultimately becomes 1 by beta from there, right? But in all the other cases, it grows with S. So exponential, negative exponential, Hill curve, and S curve. So S curve is the most generic form, and it's given by the Hill saturation equation, which is most commonly used for the saturation function, the saturation transformation that is done in marketing mix modeling. This is what I was saying. You actually need to do some sort of statistical modeling to arrive at a true definition and a true calculation for marginal CAC. Otherwise, you will never get a right answer. And then we also have logarithmic. So I'm not obviously going into the equations. You can look at this if you are mathematically inclined or you're already aware. You must understand from where we are getting the average CAC, the marginal CAC for each of these cases, and the respective ratios for marginal by average. And yeah, like I said, the ratio doesn't remain constant in those cases. Only in the power case, which is the simplest case. So by the way, all of these are diminishing returns or response curves. All of these make sense in the real world of advertising. All of these can be applicable, but we see that the most general case is the Hill curve or the S curve, but you can also start with the power curve as well. It's not a problem. The proposition here is that you don't just use average. Certainly don't use average CAC. The concept of even the simple definition of delta cost by delta customers, that isn't really a proper mathematical definition, but it's at least a good place to start. But once you've been there, why just remain there? Why not take a step further and go for a more mathematically robust definition of marginal CAC? And that is given by this approach that I was talking about. Do keep that chart handy. That's a very useful one. It gives you everything. If you want the mathematical versions also, yeah, those are available in the video. I've already shared those. And that's pretty much it, actually. I hope that if you're a marketer or an analyst and you're interested in these things, this video should definitely be useful to you. And yeah, if you have any questions, do let me know in the comments. Always happy for meaningful conversations. And if you like my content, do give this video a thumbs up and subscribe to my channel. And thanks for watching. I'll see you in the next one.